again. So what we're going to look at now is to check how accurate our first function that we find is. So I just did a little bit of quick maths and found a function for my points here. So I type it down here in the input bar. If you can't see it, just go up to view and make sure you have input bar ticked. So you must type y equals, and if I just very quickly type my function in, 1.252 sine. Make sure you put brackets after the sign. Now I left my b as a fraction, so I'm going to put this in brackets, 360, and you have to put it in as a divide. Divided by 13, then in the next bracket, x. Now this is very important, you must put the degree symbol after the x, otherwise your graph will look very strange. And then I've got plus 16.232. Oops, I forgot the point, 0.232. Enter. Okay, there's my function, doesn't look too bad. And I can see up here, you can see what the function is. It's just rounded it, but I think what it does is it keeps in its memory the big long decimal if you have more than 2 decimal places. So don't worry too much about that. Let's just make that a bit smaller. So I can see here my graph doesn't fit too badly, and what I want to know is how to actually test how accurate it is. This is where our spreadsheet comes into play again. So I might just make my spreadsheet a bit bigger so I can see what I'm doing. The first thing I want to do is I want to use my function to find each of the depths of water. So what I'm going to do is I'm going to get the spreadsheet to substitute my time, each of my times, into my function here, so I get the depth of water. So it's the depth of water that my function thinks it is. Now this is really easy to do. I'm going to call this heading predicted. So predicted, maybe I'll call it predicted depth. Okay, if I just go up there, I can stretch that so I can see the whole. Now remember with spreadsheets, whenever you put a formula in, you must put an equal sign first. Okay. You use the function name, so this is called f of x. If you have multiple functions, then by default Geogebra will call it g of x, h of x, whatever letter. So I'm using function f, so I put f bracket, but I don't put f of x now because I want to find f of 0, then f of 3, and so on. So I'm going to click on that cell, and it automatically puts the cell reference in. So this cell is cell A2, using the letter and the number, column and row heading, and that's all I have to do. I press enter, it gives me a value. So it substitutes in 0 into my function and then spits out what the depth of water is at time 0. And then it's easy, all I have to do is click on that cell again, drag the formula down, so you need to get the cross, drag it down, and there are all my predicted depths using my function. The next thing I want to see then is what's the difference between my predicted values and the actual depths of water. So here I might put the heading error, so it's the error of my function. I need to put a formula in, so I press equals, and I want to do this function, this value, that's the actual depth of water, minus my predicted depth. So I just click on the cells and they automatically go in there. Press enter, and there's the difference, so not a huge difference. If I go back up here, get that cross again, click and drag, and it finds it for all of them. Now the problem I have now is because I want to find on average how much for each of my points, that real points, how much is my graph off by? So obviously I get some positive answers and I get some negative answers, and if I average them, I won't get a real indication of what's happening, because for example here, if I see I have positive 0.02 and negative 0.02, and when I add numbers up to find the average, they're going to become 0, which is not true. So what we do is we take the absolute value. So I'll make my next heading absolute error. Enter again, I'll just stretch that so I can see the heading. And so all I want to do is I want to take each of these numbers and take the absolute value of each of them. So click in the cell, equals, because I'm going to put a formula in. And Geogebra just uses ABS, as does many pieces of software, for absolute value. You must put a bracket in, and then you just click on the cell. I want to take the absolute value of this number. Remember, all absolute value does is it just takes the number and makes it positive. Press enter, and there we go. Click, and then drag down, and we can see all of these are now positive. What this then means is I can now find the average of these, and then I get a little bit of an idea of how close or how far away my function actually is. So if I come down the bottom here, I'm going to type in mean error, enter. Might make that column a bit bigger so I can see it. And I'm going to find the average of these numbers. I'm going to put a formula in, so I click on the cell, I press equals, and if I do average, bracket, and if I just highlight whichever ones I want, so I want the average of all those cells, and let go, and press enter. Oh, no, that didn't work. Let's go back, get rid of that. Let's try mean of those numbers. There we go, that works better. So just highlight that just to make it stand out a bit more. So my mean is 0.03. That means that for each of my points in time here, the 0, 3, 6, 9, I think they were in hours, then my function or my curve is actually only 0.03 meters off at each of these points. That's actually not a bad mean error. And it gives me an idea at least to see how close or how far I am. Okay, hope that was some help. Good luck. Bye.